I'm working as a AI researcher at Optimum AI. So today we'll start with clustering. We covered the supervised learning, all the supervised learning algorithms, classification and regression, and we were left with unsupervised learning. In unsupervised learning, I'll be covering a clustering algorithm. So I'll start with it now. So what happens? I hope my PPT is visible to everyone. Can somebody confirm in chat? Is my screen visible? The presentation screen? Okay. So we have two types of learning as we learned. First is supervised and then second is unsupervised. Unsupervised learning, we already had labeled data and what we were doing is we wanted to segregate the new data point, whether it belongs to class 1 or class 2. But in unsupervised learning, we don't have any labels associated with our data. So you can see in the picture, the supervised learning has two different categories, whereas in unsupervised learning, there is a single category. Now, in this single category, as I took the example of customer segmentation yesterday, you need to group the similar data points and you need to form clusters. So suppose now how this algorithm executes is that you have your data points and start you start by choosing a random point as the center of the cluster called centroid, and maybe in this case like you've chosen two centroids. Now for these two centroids you'll compute the distance of each points with both of these centroids, and whichever point is closer to the centroid, say for red centroid we can see that this point is closer, so we'll assign this point to the this red centroid. And here also for this one, we computed the distance from the red centroid and the blue centroid, and we found out that it is closer to the blue one. So we'll assign this to the blue one. Now, once we have done this, we would get some arrangement like this. Now, after this, what we do is we again recompute the centroids by taking the average of all the points, and wherever the average lies, we'll consider that as the new centroid. And again, from the new centroid, we calculate the distance of the points, and whichever point is closest to whichever centroid, we assign that point to that centroid. So this process keeps on repeating until and unless we reach a point where we see that our algorithm has converged. So like it is going some n number of times, and now finally we see that we've got such cluster centroids. And if you like recompute the centroids, you'll see that you get the same centroids as the value. There are no more shifts or changes. So that is the point when we say that the algorithm has converged. Now, the same thing I've documented here as the algorithm. So we randomly initialize some K cluster centroids, and then we repeat the process of assigning all the data points to the closest centroid. And then we move the cluster centroids by computing the average of the points assigned to some cluster K. Now, how do we decide the optimal number of K, or what should be the number of clusters we should be forming? That I'll show you in the code. So I'll move to my coding notebook. The example which I've taken for coding is the same, the customer segmentation example. So we'll first import all the libraries, NumPy, Pandas, and Matplotlib, and then we'll import the data set. Now, once you import the data set, this is how the data set looks like. It has the customer ID, it has the gender, it has age, it has the annual income of the customer in dollar, and it has a spending score. Now, the spending score is such that higher the value of the spending score, the customer spends the more. So it's like a relative. So if it's 100, the customer spend the most. This is how we compute, like this is how the data set is, and it's a clean data set since we've already studied about EDA data processing like multiple number of times, and we've covered it all yesterday. So I've taken a nice clean data set right now for computing this clustering. So how do we compute what should be the number of cluster centroids? So for that, we have a method which is known as the elbow method. So what does it do? So you just need to say consider if considering your data, you decide that I'll choose the number of centroids between the range 1 and 11. So 1 or 10, 1 to 10, I'll choose whatever is there. I'll choose the centroids that way. So what you basically do is for each cluster, suppose if you take the value of cluster to be 1, you execute the k-means entirely and you compute the WCSS. Now, WCSS is basically the metric which we use to compute the cluster centroids. So it's what happens it computes the distance of each point with the cluster centroids, and as if we have one cluster centroid, what will happen is that the distance will be large, right? There would be points that are located from a larger distance with the current cluster centroid. So this is the sum of the squared distances. So then you repeat, like you recompute the WCSS value for like taking the cluster just to be 2, you recompute it. And when you finally plot this graph, you will get something like this. In this case, you see the when you started with cluster 1, you see the value is very high, and slowly as you increase to the number of clusters, the value keeps on decreasing. Now, why it keeps on decreasing is because we compute the distance of the points with the nearest centroid. As we increase the number of clusters, what will happen is the distance between the points and the centroids will decrease, right? So as we increase the number of clusters, we see there is a decrease. Now this shapes looks like the elbow. We have like it's a part of the human body. Now, how do we decide the optimal number is the point where we see there is a sudden sharpness or there is sudden decrease. We choose that as the optimal number of clusters. Now here you can see at this point, you see that till this point there was a rapid decrease, and after this point it started decreasing slowly. So you choose this point to be your optimal number of clusters. So in case, like in this example, the value comes to be 5. So once you've chosen the optimal number of clusters, that is 5, what you do is you simply run the k-means algorithm. So in order to run the k-means algorithm, we just import k-means. So it's already done here actually while computing the clusters. So I've imported k-means from scikit-learn.cluster, and then we provide in the number of clusters, and then we initialize with k-means plus plus. Now, k-means plus plus is nothing, but the only difference is, like I said, we randomly initialize points to be the centroids. In k-means plus plus, we don't randomly initialize, rather we choose the farthest points as the centroid cluster so that we don't get trapped in the trap of randomization. So I would recommend you all to search and read by your own what is the difference between k-means and k-means plus plus so that you get more knowledge about it. And then I've set random state to 42 so that every time either I execute or either someone else executes, the result stays the same. Now, once we have done this, we can call the fit predict method. So it will have all the values are like all the clusters here. And now what I'm doing is I'm just simply visualizing this so that you know how the data set looks like. So since we have taken the number of clusters to be 5, we'll have 5 k-means values 0, 1, 2, 3, 4. If you see this diagram, see how beautifully it has segregated all these clusters. And what intuitions can you derive from here is that based on annual income, you see there is a group of people who have low annual income as well as they spend even low. But there is another group of people, those who have lower annual income, but their spending score is quite high. And then there is a set of people who are on like average and their spending score also is average. There's another group of people who earn very high, but their spending score is low. And there's other group of people who earn very high salary and they also even spend more. Now, as a shopkeeper or as the owner of the mall, what you'll do is you'll target these group of customers, basically those uh, who have medium income but their spending score is medium. So what you'll do is introduce some schemes or discounts to so that they start spending more, and then you'll introduce some other discounts like if you pay through the credit card, then you get this much of cash back, or you get this gift, or you get some money returned back. So all these kinds of people who have high income because they're probably to have some they must possess some credit cards, but they might not spend a lot because maybe they are like lazy to spend, or maybe they're looking for some offers and things like that. So this is how the k-means clustering algorithm goes on, and I showed you the code as well. So by this, we have completed the supervised learning. We have completed unsupervised learning. And now we'll move on to artificial neural networks. So what I'll do is I'll cover the basics of artificial neural networks and I'll show you one code example. But in detail, the entire topic would be covered by one of my colleagues, Swati. So I'll just introduce you to the TensorFlow and I'll introduce you to what artificial neural network is, and then you'll have the in-depth sessions from Monday. So before I move to deep learning and artificial neural networks, I'll introduce you all to what is TensorFlow. Now, TensorFlow is one of the library which is widely, heavily used in deep learning, and it's nothing but it's same as we what we have learned in NumPy. You'll see through the examples it's the same, but the difference lies is that it has both models, advanced models, and it can deal with unstructured data. Like it can handle the data like videos, images, and it can handle lots and lots of data, and it can leverage the use of GPUs, whereas NumPy limits itself to using CPUs and it consumes a lot of resources. So that is why you see a lot of places we have TensorFlow, and TensorFlow even has like variations. You can run TensorFlow in within the browser. You have a light version of TensorFlow that is for your mobile devices, and then you have the original version or the base version of TensorFlow. So I'll show you TensorFlow. What is TensorFlow? It's basically an open source and end-to-end platform. Like it's used for building ML models or deep learning models, and it makes use of Keras in the backend. Now, Keras is nothing. It's just another library, and it's used for building deep learning models, and it's widely used in the fields of computer vision and NLP. TensorFlow also have has an active community, and there's a lot of technical supports offered. So we'll move in how TensorFlow is implemented. So in order to implement like TensorFlow, we basically have three kinds of APIs that TensorFlow makes use of. So the first is the sequential API, and we'll be using this in our example. Now, this sequential API is a good API which can be used for things like image classification or regression tasks, and it can be used for it can be used basically for the classification and regression tasks, and when it comes to the advanced tasks like object detection and segmentation, we move to functional API. Now in sequential API, you write the code like this. You import from TensorFlow, you import Keras, and then you tell the layers, like you have these three layers, and you just pass in the layers to the sequential model. Now, coming to functional API, it's used for more advanced tasks where you have multiple inputs or you have multiple outputs and you might need to skip some connections and you have perform tasks like object detection or segmentation. So, for example, this is an example you need to differentiate where the person is, where the kite is, you're detecting what the object is. So, for these kinds of tasks, we use functional API. And this is how it looks like implementing the functional API. So you declare X separately. In case of multiple X, you declare something like this. Then you have output separately, and then you connect both of them using the model function. Now, there's another third API, which is model subclassing, and it is used for implementing custom models. And you can control every step in the model building and training part. But like I'll not be covering it in detail. I've added this for the sake of completion, and this is like you can take a look how it looks, and you can read it about more because it's in like kind of advanced topic. And will mostly be dealing with sequential API. So coming to the basics of tensors. So in the TensorFlow, we call the array or the constant or a matrix all to be a tensor. So tensor is nothing but a number or a vector or a matrix. It's just a single word for all these three things. In NumPy, we were calling it n-dimensional array, but in tensor we call it like a tensor. Basically, in TensorFlow we call it a tensor. Now, a tensor has following information. It has the shape of the tensor. It has the rank. So rank is nothing, but if it's a constant, a single number, the rank is set to be 0. If it is a one-dimensional array, then we call the rank as 1. And if it is a two-dimensional array, we call the rank as 2, and so on. Then we have axis or dimension. So basically, if it's a 2D matrix, then the axis would be 2. It would have x-axis and y-axis. And then we have the size, that is the total number of items in the tensor. Now here I have told here whatever I told you, it is all written here as well. So now what we'll cover here is we'll start with creating a tensor. Now there are two ways to create a tensor. One is constant method, another is variable method. We'll see what is the difference between constant and variable as well. So now in constant method, you just import TensorFlow as TF. Then TF is the globally used alias for using TensorFlow, and you pass in your number to tf.constant method. You print it, you see the type is tensor, which says what is the number. Shape is nothing because it's just a scalar quantity, constant, and you have the data type to be int. So it you see like I didn't specify the data type and it actually picked upon same. You can pass even a one-dimensional array. So if you pass in a one-dimensional array or a vector, you see it prints the that array. It prints the shape. Shape in one-dimensional array is the total number of elements in the array, and then it has this data type which is float. Similarly, you can even create a two-dimensional array, and you see the shape here is it has three rows and two columns, and it states the data type as well. Now you can access the dimension, like you can check the dimension by using ndim attribute. If you use the ndim attribute, you see for scalar we get 0, for vector we get 1, and for matrix we get 2. We can even create a tensor with 3 dimensions or 3D matrix. So here is like it's just simple. You just need to declare your matrix, and here you are. Like you have this. We can cross verify by printing the indent. Now, if we want to convert a tensor into NumPy array, we have two methods, and it's really very simple. You just give in the tensor name, and then you use dot NumPy function, all dot NumPy method, and it's just converted. You've converted tensor into NumPy. Another way is that you use the function NP array, and you just give in the TensorFlow name. So this is it. Like it's really very simple, and it's highly similar to NumPy array. Now, the TF.constant tensors which we have created using this method, they are immutable, like they cannot be modified and they cannot be changed. And while we are working with neural networks, you'll see that there is something called as weights, and we need to update them and we need to change them during a process called backpropagation. So we don't use this to create tensors in our examples. Rather, we use a TF dot variable method, which allows you to create mutable tensors, and we can even change the values. So it's all same, just you need to use variable here instead of constant. So here I've just added some examples. You can all go through it, and we can even convert the variable tensors into NumPy array. Now, similar to what we had in NumPy, like we had some built-in functions that would allow us to create NumPy arrays of ones or zeros or random values. We have similar such thing in tensors as well. So if you want to create a tensor that consists of polygon, you can just specify the dimension, and you can use this once method. So here there is an example. Similarly, if you want to create a tensor which has only zeros, you can use tf.zeros method to create a tensor. You can also generate a tensor which has random values. Here I have set the seed to be true. If you change the seed value is set to be true. Even if you use the seed value and you create a tensor, you'll get the same values. If I change it to 4 and if I run it, you'll see that the values change. So it's just executing, it's taking some time, got executed. So see, now the values have changed completely. But if you run the same cell again, you will see it will have the same values. Sure. Now we can what we can do is we can like even shuffle the elements in the existing tensor. For example, we have created a tensor and it has the elements in this order. We can call dot random dot shuffle method and we can pass in the tensor. And if we see this tensor, you see the items or like the numbers within this tensor have shuffled up. So one was here, but now one is here, and four was here, and it's shuffled up. Like you can use it for like again including randomization stuff in your algorithms, and it's like used widely. Now, if you want to prevent this, we can use seed like set seed method, and again, it will always remain same. So every time if you run the shuffle tensor like this function with the seed value set, you'll see you get the same results every single time. Now, selecting the data, like we talked about indexing and slicing, it's all same as we have learned in NumPy. So I've just included an example, and I would request you all to go through it in detail. It's like really very simple. Just for printing it cleanly, I've converted it to .numpy. Even if you not use .numpy, you will get the result, and I'll show you just. It's not defined here. I'll execute this, and you'll see that it gets printed. But see, it has this tf.tensor and all information. So just in order to cut it down, I've converted, I've used .numpy method. And you'll see we can do perform indexing as well. So I'll share the link to this notebook as well. And it's all same. So I'm not repeating the stuff as I've already explained in a lot of detail in the session one itself on the day one. Now we can perform similar operations on tensors as we have learned in NumPy. For example, I can add a scalar value to the tensor. See, it was 1, 2, 3, 4, and I've added 4, so it got implemented. I can even add two tensors using the plus symbol, or I can use the dot add method, dot multiply method. And what I would recommend you guys is that you go through the documentation of TensorFlow and then you see what are the other methods. Like you can implement divide, or you can implement subtract. And I would like you all can play with the code here in this notebook so that you get the more idea of TensorFlow and you get more familiar with the TensorFlow later. Now, as we learned about the reshape function in NumPy, similar to that, we have reshape function being offered by TensorFlow. Here you need to just pass in your example tensor and you need to give the dimensions in which you want to reshape, and you can just simply reshape the tensor as well. So this is it. It's the introduction of TensorFlow, and we use TensorFlow heavily in deep learning and in building neural networks. So I'll move on to now what do we mean by neural networks. I hope things are clear till here to everyone. So I hope everybody can see my artificial neural network notebook. Yeah. So at like coming to this term deep learning. So this is the subset or the hierarchy diagram. So we on the top we have artificial intelligence. So artificial intelligence is nothing but providing the ability to machines, like enabling the machines to mimic human behavior. And the best example would be like robots nowadays. You see robots, they can walk like humans, they can talk like humans, they can do movements like humans. So this is what artificial intelligence is about. Inside artificial intelligence, we have a subdomain which is called machine learning. And machine learning, we saw like we give the machine the ability to learn by itself without being explicitly programmed. And within machine learning, we have a subset which is called deep learning. And deep learning basically tries to mimic the behavior of the human brain. So in human brain, we have something called as neuron, and deep learning tries to implement, like convert that neuron, biological neuron, into a mathematical neuron. So here I have added the theory related to artificial neural networks. I'll move into the slides. Here I have made some slides as well. So I'll walk you through what is neuron and explain more. So I hope my slides are visible to everyone. So this is the image of neurons which we have in our brain. And neurons are responsible for whatever actions we take. So whatever happens externally, like our sensory organs, they are called as receptors, and we we use our sensory organs to sense, and based on that, we our neurons in the brains pass on those signals as in the form of electrical impulse, and we take the actions accordingly. And our brain directs us to take the action accordingly. So this is how neurons are connected, and here there is a process which happens which is called synapse. I'll explain you in more detail here. So we have the cell body here, and here it goes our input or whatever our sensory organ sensed. For example, your eyes saw fruit, say apple, in front of you. So it will send a signal to your with the input. Whatever I see, image that is found on retina will be sent as an input. Here it will go to the cell body, it will go to the nucleus, and it will pass on to the axon. And the axon, here it gets passed on to the another neuron through the process called synapse. Here, which passes on the electrical impulse. You see, they're not interconnected here. There's some gap, and this is how our biological neuron works. So our mind then tells us that yeah, this is a fruit, and this fruit is an apple. Now, what researchers and scientists did is that they used this concept of biological neuron, and they made a model, a simplified mathematical model, which is similar to this. So you have in your input here, then you have a neuron here, and then you have your output here. Now, why are we talking about this neural networks and deep learnings, and why there is so much of hype right now nowadays? So the reason is, as the years passed by, the amount of data we have has increased exponentially, and we have heard the phrases like data is the new oil, and like data is everything now. We have the words like big data in the market, and we have jobs related to that. As the data increased exponentially, we what we observed is that the traditional AI was not able to perform much better, even we were feeding a lot of data. But as the neural networks were introduced, we saw that there was a visible increase in performance as the amount of data increased. And when we used a medium neural network, there was even further increase in the performance if there was huge billions and billions of data. In large neural networks, they were able to do typical tasks like you see object recognition nowadays of computer vision applications, or you have this chat GPTs, the text text based applications. So by making the use of faster computer processors and good hardwares, we saw that there was like a rapid increase in the performance as the amount of the data we were feeding in increased. So that is why nowadays we're hearing a lot about deep learning, and it's the era of deep learning and big data. So I'll take an example. So I'll use a classification example. Suppose you are a shopkeeper. Again, I'm making you all a shopkeeper. And suppose if you're someone selling some nice cool t-shirts or shorts. What you want to know is that this new t-shirt or short by your own brand, whether it is going to be a top seller or not. This is what you want to predict. So basically, you want to predict the demand. So if the demand is good, then obviously your t-shirt, whatever you're manufacturing, is going to be a top seller. So it's a classification problem where we need to answer either yes or no. And if we were to do this using logistic regression or the traditional ML algorithm, we would have like used logistic regression most probably, wherein we have used, which is based on using the sigmoid function. Now, this what we would have done is we would have given the input, we would have fed this to the sigmoid activation function, and if the value was greater than threshold, we would have marked this yes, it is a top seller, and if the value was lesser than threshold, we would have marked it no, it's not a top seller. So this function, sigmoid function, in deep learning technical jargon or term is known as activation function. And we'll be using this neuron here is nothing, but it's just a logistic regression implementation. So you have your X here, you pass in your input here, and you have this activation function which gets computed, and here you have the probability of being a top seller. So this is the simplest model of deep learning, and this model is also known as a perceptron model in case the activation function we use is a threshold activation function. And this is a deep learning like neuron model with one single neuron, one single input, and one single output. So I'll tell you, we have different kinds of activation function. We'll see them within a while. So this is the problem statement. What is it about? Now you saw the simple model of neuron. Now if I move further, what if you were able to include more input features and you were able to include some semantic features as well? For example, you considered other features like price of the shirt, the shipping cost, the marketing done for that t-shirt to make it a top seller, and the material used in that t-shirt. Now, with the price, we have a term no associated known as affordability. So, is your short affordable by the masses or the group of people who buy from your shop? Was the marketing able to create enough awareness? Is the material of enough good quality? So, if you were able to add these additional features as well, it would have resulted in even being a better model, or it would have been resulted in making your model more robust, which gives the most accurate predictions. And it would be an added advantage to you as well. For example, just take a human example. If you visit a shop, if the shopkeeper asks the feedback from you, if it takes he or she takes the feedback, he next time if you visit the shop again, he'll be able to cater you better than what he did when the first time you visited the shop. So it goes that way. So this is why we can have like multiple layers here. We can have multiple neurons here, and that is the reason why we have multiple neurons. So in case we have multiple layers or multiple neurons, our architecture looks something like this. We have our input layer, we have the hidden layer, and then we have our output layer. Now, what I would show here is in a typical neural network architecture, what we have is we have our input values and we have some weights associated with these input values. Now, these weights can be higher or lower. Suppose if we want that price should influence the top seller t-shirt being the top seller more rather than quality, suppose. So we can keep the weight associated with the price higher than the quality, but we can do vice versa. So once we have these values, we can compute the sigmoid function formula and we can predict the output. So this is how it goes. Now, once we have our output value, you know what happens is we might not always have the value that matches it completely very well, matches it correctly. So we might get some error. There must be a difference between the actual value and the predicted value. So in case there is a difference, what happens in artificial neural network is whatever error is there using some optimization algorithm, like we use gradient descent, which most famous algorithm, or we use Adam optimizer. You'll learn about optimizers more in great detail in the session of deep learning. So using that optimizer, we recompute the weights here. We recompute the weights, and then again the activation function is you is calculated, and again the value of y is predicted. And this process goes on until we are satisfied with our algorithm, or we are, until the number of times we want this process to occur is satisfied. So this is how the this is like the entire basic or the entire intuition behind the deep learning and artificial neural networks. So I'll show you some examples of activation function. We have threshold activation function, which gives says the value to be 1 in case the x is positive and the value to be 0 if the x is negative. We have sigmoid activation function, which we have already learned and covered in classification algorithms while we were studying classification algorithms and we studied about logistic regression. Other than this, we have a very famous activation function, which is ReLU activation functions, also known as rectifier linear unit. So it takes the function is like it takes the maximum of the current x or 0. And then we have this hyperbolic tangent and activation function. And all these activation functions have different significances. So for example, a sigmoid activation function is used mostly when we are solving the classification problems. ReLU activation function can be used when we are dealing with regression problems and where we don't expect the value to go negative. For example, if we are predicting the price of the house. So in that case, the house of the price of the house can never be negative, right? So we can make use of ReLU activation function there. And we'll see how we actually use this in code. So this is it. Now coming to the optimization algorithm, I'll just give you an idea of what optimization algorithm is about. So suppose you got the value of the output here, you have your model, you computed the value of y, you got some value. Then you computed the difference between the actual value and the predicted value. And you plot it here, you plot the difference here and the actual value here, and you got the error or the loss, something like here. Now again, since you're implementing gradient or descent or you're doing something, you're using some mathematics, you recomputed the weights and then you got the new value of y. So you see the cost got reduced or the loss got reduced. So once you keep on repeating the process, you will reach a point where that value of y which you predicted would be the best value. And in case you keep on refining it, if you keep on changing the value, you see that results just keep on getting worse or the cost increases. So you'll get something like this, the shape of bowl or this curve, something like this. So what your goal is that you need to reach this point. So this is what gradient descent does. So it runs and it computes the cost and it finally stops at the point where the cost is minimum. And how does this happen? So it makes use of mathematics concepts like a differentiation and it computes the minimum. You have heard about global minimum. It computes the global minimum and here it converges. So this was like introduction to the optimization algorithm, and we've covered the introduction to artificial neural networks. So, but I'll now just won't take your much time, and I'll walk you through an implementation of artificial neural network. So the very first thing we do in the code, I hope my screen is visible here. So what we do is we import the libraries as the very first step. We import NumPy, Pandas, and TensorFlow, and then we start like we import the data set. So the data set which I have taken here is it's a churn modeling data set. So what does churn modeling means is we need to find out how likely is this customer to uh, like how likely is this customer to churn or leave this bank. So we'll not issue the bank will not issue the credit card to that person. So basically, the bank people are deciding whether the credit card should be issued to this person or not. He's a good enough person or not. So that is what this problem set is about. So we have the details of the people who are associated with the bank, who have their accounts in the bank, and we have some metrics here. So what we'll do here is that let me show you the data set. Now, just a second. So this is how the data set looks like. So you have the customer ID, you have the surname, you have the credit card score, you have the geography, the gender, the age, tenure, balance, number of products. Does he has the credit card? Is he the active member? What is the estimated salary? And what is the chance like the customer exits or stays? The one stands for the customer is likely to be exited, like he'll not probably is not a good candidate for the bank, and zero is he'll not exit. He's probably likely to pay his bills and debts and loans all on time. So again, coming to the code, I showed you the data. I'm not going again through the pre-processing steps. We've already covered it all in great detail. So we're importing the categorical data. Here and I've used label encoder, and here I've used one hot encoding for the another column. And once we have encoded the data, we make the train test split here, and we have considered 20% of data to be the test data and 80% of data to be the training data. Now, further, I've performed feature scaling. So I've used normalization here so that the entire data set is properly scaled up. Now comes the main part, building the artificial neural network. So in order to build the artificial neural network, you first initialize the ANN model. So as we've imported TensorFlow, we hit the sequential API and we create an object of sequential API. Once we have hit tf.keras.model.sequential class and we have created an object of this class, what we can do is we can add a first layer here. So what we are doing is we are adding the first layer and we are saying that we want 6 neurons and the activation function, like what we are using for that neuron should what the neuron should compute. We are using activation function as rel, and it's widely used, like ReLU is widely used when it's solving problems in ANN. And there can be cases like you can try it with a TANH or another activation function. Now, once we have added a first input layer and the first hidden layer, we'll go and add a second hidden layer. And the second hidden layer also has 6 neurons, and the activation function, again, I've used rel. Now, since you saw that the data set, we are finding whether the customer is likely to exit or not. So it's classification problem. So the output layer, what it will have a single neuron, and we'll make use of sigmoid activation function, wherein we just want our answer either it to be a 0 or 1. So this is how our output layer looks like. So once we have these layers separately. What we need to do is we need to compile this model. We need to connect these layers. And for that, we have compile method. And in compile method, we pass in our optimizer as pass in the optimizer. So you can try with the gradient descent, which I told you. Adam is another optimizer, and it's an advanced and very nice optimizer. So I would suggest you all to go and read about atom. And we compute the loss at every step. So as I said, the difference between the actual value and predicted value will compute the loss. And here we have taken binary cross entropy. Binary cross entropy is nothing but the loss we calculate in the logistic regression function that I showed you yesterday. It's known as binary cross entropy in deep learning. And the final metrics which we use for evaluating how good is the model, we use the metric called accuracy. So if you have gone through the classification notebook yesterday, which I've shared, and the assignment which I gave you, you would have seen some notes on accuracy as a metrics for the classification problem. So this is it. It's all same. Now, once we have compiled our model, we have specified these values. The next step which we do is we need to fit in our model. So for fitting in our model, like we need to tell the model like, hey, this we need to fit in according to the input data which I'm providing. So I provide the training data and I here you see two terms, batch size and epochs. So what epoch is basically one full cycle through the entire training data is known as epoch. So once your device is completed for all the training data, we call like it has completed the entire pass through the entire training data set. We call it as one epoch. And what happens is when one epoch is completed, the weights get updated. But in case the data set is huge, if we wait for the epoch, one whole epoch to run, it might take some time. So what we usually do is that we divide the data set into batches and we perform multiple iteration. Now, what a batch is, we can consider or specify the batch size. Here, I have taken the batch size to be 32, which is even the default batch size. So at a time, only 32 samples from the data set will be picked, and we'll go through forward and we'll compute the value of y, and then the weights get updated. So, for example, if you have 1,000 training samples and you set the batch size to be 500, you need two iterations so that your one epoch gets completed. So, I've added this theory so that you can read it and it makes you clear about the concept of batch iteration in epoch, as a lot of people are confused with these terms and terminology. So once I call the fit method, what you observe here is that in the first epoch, the accuracy is somewhat 85 and the loss here is zero point 0.3. Now, as I go further, you will see that the value of loss keeps on decreasing. We don't have a huge data set. Won't see a subtle, like you see a sudden increase in the accuracy and decrease in the loss. If you were dealing with a heavy data set, large data set, you would have observed a lot of changes here. So at every step, you see there is this change in accuracy, and the loss keeps on decreasing, and the accuracy keeps on increasing. And at the end of the last epoch, you have the final loss and the final value. So you can see the loss and accuracy to be here. You need to decide the optimal number of epochs. If you keep the epochs very high, if you use a lot of epochs, then it might not be the case that it gives you very good result. Usually, you need to decide based on your data, based on your business use case, based on your understanding what should be the number of epochs or how many times do you want this algorithm to run. Now, here I've used the summary method just to show you how the model looks visually. So we have a first layer. We have herein we have your inputs present and batch size is 32. So you see here 32 and we have 6 neurons. There are total these many parameters associated with this layer. We have a second hidden layer here and this is our final layer called dense 2. It's our output layer. And this is the entire information about our model. So you can use summary to get an idea what kind of model we are building. Now, once we've built model, we have used the model, we have fit the model according to our problem statement. We will make predictions and we'll evaluate the model. So for you, the homework is like you need to go through this notebook entirely. You need to understand the code and you need to predict uh, that whether the person who has these values, this information is is he likely to make an exit or not? And if we like yes, if exit is yes, then it means like we should say goodbye to that person. So you need to answer this question. You need, I have provided a code block. You need to write it. It's a single line of code. You need to write in here. So this would be your assignment as well. So what I've done here is I've predicted the tested results. So here what I get on using the predict method is we get probability. What I wanted, the threshold, what I've used here is I've set the threshold to be zero point 0.5. So in case if the value or the probability is greater than zero point 0.5, I set it as 1, otherwise I set it as 0. And I'm making confusion matrix and I'm using accuracy score to predict what is the accuracy. And you'll see on the test that we get an accuracy of 86%, which is not a bad accuracy, nice accuracy, which we've achieved. And this is our confusion matrix. We see that there are 74 and 201 uh, true positive, like false positives and false negatives. So this is it for the introduction to artificial neural network, and this is your code notebook which you can go through. So I've kept it simple, and I hope you got an idea of basically why do we need deep learning, what is deep learning, and what is artificial neural network. Now I have one notebook which I was showing here. So here you can read about artificial, like the deep learning more in detail. So I've stated why deep learning, whatever I explained, I've mentioned it here. I've mentioned the diagram. I've mentioned the activation functions. Then there is something called densely connected neural network. Basically, if all the neurons are connected to each other, then we call it as densely connected neural network. And then you have convolution neural network, which are used to deal with the image or the video data. And there is recurrent neural network, which deals with the like you have audio and speech processing, audio text processing. So herein we use recurrent neural network for such use cases. So you can go and read all these in details, and all these would be covered in great detail by Swati from Monday. So I hope this session was good enough and you have all have learned something new. And I would like to keep today's session short as I would like to end up machine learning introduction here, and I've covered probably all the important things that were required that you all guys should know before you move on to further advanced topics. So I hope I was able to add some value to your life, to your knowledge the past 3 days, like today and the past 2 days, whatever you've learned. If you have any questions, then I would want you all guys to ask me. Otherwise, we can end this meeting right now. Okay, Yaban, I'll share the notebooks as well. Yeah, I know it would require some time to get you all through this information, but you will, if you go and read on these notebooks and if you have any doubts,